Hey everybody, and welcome back to another video in this series. So in today's video, we are now going to be taking a look at the additive mesh spaces that are in the game animation sample and migrating it over and doing stuff with it here in the GASP from scratch template that we have. So let me go ahead and pull over what we're specifically going to be working on and what we're going to be doing. So if I pull over my GASP from my GASP template here, you can see that what I want to go over today is the simple additive lean. So one of the things that you'll notice that when we do play, our GASP character and stuff like that, as we're going forward, you'll notice like as we, turn around or, look in different directions as we're running forward, how our character wants to lean, right? So that is essentially what this is doing right here by using this additive mesh, where it is applying this blend space onto our character and only is working when we're moving. So what we're going to be doing is we're going to be specifically working on this today. So in order to get started, because we're going to be working on this in the next video, we're going to go ahead and migrate all of the animations into the GASP from scratch template that we have been building up till now. So I'm going to go ahead in my content drawer, and as you can see I already have it open, but to get there you're going to go into content, and then you're going to go into characters, the UEFN mannequin, the animations, and what we're going to do is we're not going to go into any specific one. We're just going to click on one of them and then shift click or control A to get all of them, and let's go ahead and migrate them all over to our GASP from scratch template. So in this case, I'm not going to be separating anything. I'm just going to go ahead and take all the default stuff that's a part of that and just throw it into, our template. So let's go ahead and hit OK. And then I'm going to go ahead and look for my project. So for this, it's going to be under my GASP tutorial and then the content folder. And then I'm going to select folder and migrate. So this is definitely going to take a minute. So I will definitely see you guys in just a bit. Alright everybody, welcome back. So now that we've got everything migrated over, and basically what I did do too is I made sure to overwrite anything, because I couldn't remember if from the character blueprint series or if we did anything in this series that involved migrating anything. I think it was just pretty much the character blueprint series that we migrated some stuff. So if you did follow along with that series and migrated some stuff over and it prompted you for overwrites, just go ahead and hit yes to that. It shouldn't really affect anything. But then as you can see is like once you've gotten all the assets migrated over, that you should now have, the audio stuff, additional blueprints, like the ABP sandbox character and whatnot. And then, the different characters like our UEFN now, and then the other stuff, right? So what we want specifically in this, because we want to do the additive lean, right? And that's why we wanted to migrate over, just to have all the animations anyway, in case you wanted to mess with them in the game animation and sample project template that we're doing. But basically for the lean run that we're going to be focusing on is if you go to the characters, UEFN mannequin, animations, and then in the run, you will then see the BS1D additive lean run. And this is the thing that we need in this situation right here, because this is what we'll be working with. So as you can see as I hold my control button, that it is doing additive leans, right? Or not additive leans, but it has, 3 different blend targets that it's creating that lean, action with, right? So as you can see over here in the blend samples, that you have the, let me move over this, that you have the neutral, run, lean, pose left, and then the pose right, and then the base. So you have your base in the middle, which is what this is, and then you have your pose on the right on the, as you can see, the 1 value, and then you have your left pose on the -1 value. Because when you think about it in this space, so let me go ahead and hang it over here. If we go into our character and look at our first person or our third person, as you can see, when we actually look at our character from behind when we were running, you'll see that the X going this way to our left would be your negative. So anytime on a math graph or anytime in any world spaces, the left is always going to be your negative space, or at least like -1 or whatever, in that regard, while the right side is always going to be your positive. it just looks wonky when the character is essentially looking at you. But if you were to turn it around in this fashion to take a look, you can see that as we go more towards the left, that we get that left lean, and then when we go towards the right, we get that right lean. So that's pretty much what we'll be using and making functions for in this video. So the reason we migrated it is because I don't want to have to recreate this that's already been provided in the game animation sample project. Unfortunately, I'm just not an expert blend spacer yet. So, I say that jokingly, you don't have to be an expert, but I'm just not that well learned on blend spaces like that just quite yet. So that's why I wanted to migrate the asset over, just so that way we already have it. So now that we've taken a look at that, let's go ahead and, just close out of it. And what we're going to do specifically is we're going to migrate this blend space. So what we're going to do is within the, I believe it is asset actions, or no, I'm sorry, it's retarget animations. My apologies. We're going to retarget this to our Manny skeleton as soon as this thing loads up for me. Unless it just stalls and gets stuck. Any minute now. Well, bear with me, guys. I'll be right back when this comes up for me. Alright, guys, it eventually popped up for me. I don't know why it stalled like that on me right there, but now that it's back up and running, we can go ahead and get that retargeted. So now that we're in the retarget animations, what we want to do is for our target skeletal mesh, we want to go into here and we just want to find the SK Manny. So right here, the SKM Manny. You can definitely choose the simple and whatnot, but because we're messing around with a bunch of Manny and whatnot, it should also apply to our Quinn, who is a child of Manny. So as long as we can get this retargeted to this, I believe we should be fine anyway. So once you got that, and going through it, just make sure that we select the blend space 1D right here, and then we're going to export the animations. And what I'm going to do is I'm going to go into characters, and I'm going to go into mannequins, and then I'm going to go into animations, and then Manny. But what I'm going to do is similar to the UEFN character, where I'm going to have a folder in there called run, and I'm going to retarget that here. So I'm also going to give it a prefix called GASP, so that way we know what it is, where we got it from, and whatnot. So I'm going to go ahead and export, and then since there's nothing there, we didn't already do this, I'm not overriding it. We want the referenced assets, so go ahead and export. And now you'll also see that it comes with the actual leans that it used in this blend space. So now if we close out of this and we go back to the content drawer and we go to characters, mannequins, animations, and Manny, you should now see that we have a run where we have the additive leans and the things that came with it. So with that being said, let's go ahead and add that to our blend space. So I'm going to go ahead and move over the states and the locomotion stuff for a brief moment. And just another thing too, to inform y'all is that, you might experience some glitchiness and stuff like that as we've been doing this series with the animations and making the modifications everywhere in the root bone, leg IK, etc. And I highly suspect, because we still have our locomotion state machine that has our animations and our jumps and stuff like that within this that are probably conflicting with each other, which is my guess. So just for the moment, kind of bear with it, but eventually once we get the motion matching nodes and stuff in here, we will be deleting these to where animations should hopefully start working properly. But until then, when I finally get to the end, I won't know until then. So, but for the moment, let's go ahead and get into this. So the first thing that we want to do is we want to go ahead and grab our apply mesh space additive. So look for apply mesh space additive. And as you can see here, it applies a mesh space additive animation to the normal pose. So kind of what the dev notes have essentially, you know, it's gonna apply our left and right leans, because what it's trying to do is, you know, as it does the animations and stuff for our normal pose, or our normal running pose, so to speak, because we're gonna be setting this to when we're moving, is that, you know, after we do add the calculations and stuff into here, you know, with our blend space, you know, it'll appropriately lean us left and right, or add that animation flow into our base run animation. So I'm gonna go ahead and connect this into the local to component and the main states into the base. And then now what we're going to do is we're going to bring in the BS1D additive lean run, which should be our, let's see, I think, okay, this isn't the one that we are looking for. I think this was the pre-made one for the Manny and Quinn. Ah, yeah, because we called it GASP, that's right. So we want the GASP one. See, that's why you got to separate it. So we're going, first what we're going to do is we're just going to plug this into the additive, because we do have to make a function. We have to make two functions for this within our character to be able to utilize within this. So let's go ahead and create those functions now before we continue any further. So what we are going to do is we are going to go over here to functions and hit plus, and we're going to call the first one get underscore lean amount, just like that. And then what we're going to do is we're going to go down here into our variables, and we're going to go to, I believe it is essential values, and we're going to grab our ground speed. Then off of our ground speed, we're going to get a map range clamp node. So just like that. And then what we're going to do is in our A range, we are going to put 200. Within our B, we're going to put 500. For our outrange A, we're going to put 0.5, and then for our outrange B, we're going to do 1. And I'll explain what this is doing in just a moment. I just want to kind of get the nodes in place first. So then we're going to go into here and get a right click into the space and grab a multiply node, and we're going to attach the return value into the second node. And then we are going to, off the input function or the start function, we're going to get a return node, and we are going to place or connect the return value to that. So what we're going to do, or actually real quick, I forgot, we do need to actually convert this. So we do need to make this a vector 2D. So actually let me disconnect that real quick and make that a vector 2D. Because what we're trying to do is get a certain value from that, and so we need to split the struct pin, because we want to make it on the x-axis. Because if we would have just kept it as a float, it would have, you know, added it all the way around, like on the x-axis, y-axis, z-axis, stuff like that. Because what we're about to do now is create a function to get a vector value for us. And be excited for this one, guys, because I did have custom notes for this one, because I had to make sure of what was going on so I could properly explain this to y'all. So be on the lookout for my special notes now. So now that we got that, so to explain briefly what's going on in here is when we make our function, because we're going to be calculating relative acceleration, and then we're going to be multiplying that, you know, off of one of the following outranges that we are clamping our ground speed to for the in range. So anytime our ground speed is in between like 200 to 500, we will output these ranges. And what that'll do is when we do get the acceleration and then we move in a specific direction, and that will be multiplied to with between one of these two values to then get an X value of like 0 to 1 or 0 to -1 that will then allow our character to lean as we are running forward. So I'm going to go ahead and compile and save this for the moment. And yeah, so I like how everything just broke. That's actually pretty interesting, but I'll worry about that in a moment. So it's probably because of the additive mesh. We don't have anything confined to it yet, so I'm pretty sure that's what it is. So I'm going to go ahead and do a new function. We're going to call it calculate. And let me make sure I spell it correctly. Relative acceleration amount. Calculate. Yeah, see, I messed up calculate. Calculate relative acceleration amount. Perfect. So we got that. So now this is where I'll be going through sections at a time to explain what's going on for y'all. So what we're going to be doing first is we're going to get two property access nodes. So go ahead and into the space, right click anywhere and look for property access, because we want to access specific values off of our character while making this thread safe. So, or at least thread safe to a certain degree, because we're not, yeah, because I believe we are making it thread safe. Yeah, it is going to be pure and thread safe. So off of our bind, what we want to grab is we want to look for our character movement. So since we have it labeled as movement component, we didn't make character movement within our, third person template or our GASP template. So off of movement component, what we're going to get is the max acceleration. So right here, it should be get max acceleration, or let me see, it actually has it as something else. So movement component, and let's just look for max acceleration. Yeah, so we want, let me do this, max acceleration. I just need to go straight down. I keep forgetting that it'll be fine if I just do this. So we want this one right here where we get the rate of change of velocity. We want the actual variable, not the pure function. So this is what we want as far as that's concerned. And then I'm going to copy this and paste it. And then off of here, what we're going to do is we're going to get braking acceleration or deceleration. So off here, we're going to look for deceleration, and we want, I believe it is just get max. Yeah, so we want this specifically, because what this pure function does is, I don't know why. Oh yeah, because I accidentally did that. So, because if we look at it, so if we go back to deceleration to look at it, so decel, am I not on the right thing? Let me just look for brake. Oh, so why is it not working now? Let me see if I go in here. So let me undo that for a moment and then repaste it. I don't know why it's doing that. It just converted to that. So let's do deceleration. So what this is doing for braking deceleration is pretty much kind of encompassing, or should encompass, all of these in there. So that's what's going on in there. Because if we go into our third person character template and we go to movement component, you'll notice that we have acceleration, where we can get our max acceleration here under the character movement. And then for the deceleration, you'll notice how there's not a specific deceleration. It's just decelerating for flying, swimming, jumping, falling, and walking. So what this is doing, or what it should be doing, is retrieving the deceleration for each type, depending on its checks that it does. So if we're walking, it's going to get the walking deceleration. If we're flying, get the deceleration for flying and stuff like that. So that's what we're doing here, is we're trying to retrieve the maximum acceleration value from the character movement component, and then we're trying to retrieve the maximum deceleration braking value. So now that we got that, I'm going to go ahead and add my custom notes into here. So we got that set, make that group movement, and then we have comment for here. Should just move it around in there, to be honest. So yeah, let's just do that. Make sure it sits nice and pretty. And there we go. So now we got those two set up and ready to go. So now the next thing that we have to check is to see if they're greater than specific values. So the first thing what we're going to do is we're going to grab two greater than nodes. So right here, we're going to get a greater than, and we're going to copy it and do the same thing and put it down here. Because what we're trying to do is we want to see if both the deceleration and the acceleration are greater than 0. So, with the, as long as they both are greater than 0, then we're going to end up going through the true value and like just continue through our function. So there's not, really anything more to that. It's just that we want to make sure that these are just greater than 0 values, because like when you are accelerating, it is going to generate a greater than 0 value. And when you are decelerating, it actually does generate a greater than value. So because it's decelerating as it's like slowing you down. So it's like weird to see. It's like kind of going in the opposite way. So let's go ahead and grab an AND Boolean and connect these two puppies into it, just like that. And what I'm going to do is I'm going to slide these down just because I want to be able to put my notes in here. And so off of this, we're going to grab a branch node. So that way, if both of these are true, then we just continue off the true. And if it's false, then we just don't continue at all. So go ahead and move that over, and let me go ahead and put my notes in here. Gotta grab it first. There we go. And then let me prettify this real quick for y'all. Boom. Like I'll keep missing that. All right, so there we go. So now we got that set. So now the next part, and I've went over this in a couple videos before, so I'm always going to go over this whenever this happens, because this can be a very confusing variable to use. But we are going to be using a dot product for this next thing. And so first, let's go ahead and just place out the nodes, and then I'll go over what's happening. So what we need now is, in our essential values, we need to grab both acceleration and velocity. So because stuff that we set in the event graph under the essential values, we're now going to be using acceleration and velocity, and then we're going to actually be tampering with the velocity acceleration now. So we're going to grab a get acceleration and a get velocity first, and then what we are going to do is we are going to then look for a dot product right here. So as you can see, what it says when we hover over it, it's very vague, but it returns the dot product of two 3D vectors. So like I said, when I hook these up real quick, I will go over what they are. I just want to put up the nodes first. So we're going to be checking to see if our dot product is greater than 0. And if that is true, then connect this to branch, and we are going to now have true or false conditions. And so connect that into the first branch. So now essentially what this is doing is we are, with the dot product, what we're trying to calculate the dot product between the acceleration vector and the velocity vector. This value indicates whether the acceleration is going in the same direction as the velocity. So that's what this is doing, is it's like pitting two vector values against each other to see if acceleration is going in the same direction as velocity, or if we're going against it, or if we're going, in a balanced direction from it. So I'll go over that in just a second, but basically whenever you want to pit something against each other with a dot product, make sure that whatever you're trying to pit with is at the top. So I will say this is also useful if you're trying to do a simple pivoting pure function. If you're making your own motion matching database, you will always want to do this, except what I recommend doing is probably setting the greater than value to probably something like 0 or 0.5, because one of the things that I've done in a previous video is I normalize these values in order to turn them into 1 or -1 values. So because if we get what we get right now, basically the acceleration is going to hit up to our max, which is going to be 1500, while the velocity, could be whatever we have set in the character blueprint, get walk speed and stuff like that. So with that being said, if a positive result is generated by pitting these two against each other, then that means that acceleration is going in the same direction as velocity. A negative result is the acceleration going opposite of velocity. So if we are going forward, we are accelerating forward and our velocity is picking up a positive direction, meaning because we're going forward. If I suddenly try to pivot and turn backward, then the acceleration gets pitted against the velocity, generating a negative number because now our acceleration immediately goes backward and our velocity now has to catch up to then, go backward. So that's how a negative number gets generated. The zero result is, say that, we're accelerating and going straight forward. And while we're going forward, I just immediately took like a left or a right turn. So because we're going perpendicular now with our direction, we're not going against velocity. We're going, to a side or a lateral movement. That causes a zero result, so it's not going to do anything. So that's what's going on here. So what we're going to be doing is, off of the true, we're going to be checking if the character is accelerating, and then false is going to check if our character is decelerating. So let me go ahead and move my comment node over here for y'all. And there we go. Got that set. So now let us go ahead and get into the first part. So now what we're going to do, and we're going to get out our nodes little by little, is now we're going to get believe we can just reuse this. Yeah. So we're going to grab our property nodes again. So you can just go ahead and copy the movement component max acceleration and put it up over here. And then you can grab the braking and you can put it down here, because our false, we're going to be checking if, off of our false, if this is false, that if we're decelerating, because technically our acceleration goes against our velocity if we just immediately stop or we're trying to decelerate. It's technically getting pitted against the velocity, which will generate a random number. So that's why you want the false to be your deceleration. So now we're going to grab our velocity acceleration, and what we're going to do is we're going to clamp our velocity acceleration by using a vector. If I can spell clamp, and we want size max, and we're going to clamp it to our max acceleration. So that's as high as it can go, is based off of our max acceleration. Then what we're going to do is we're going to then divide the vector clamp, if I can find my divide, by the max acceleration. Because what this will do, because technically what you could do is grab velocity or just acceleration in general and divide it by max velocity, because what this is doing is trying to get a 0 or a 1 value, because we want to make sure that our velocity is clamped to our velocity acceleration is clamped to our max acceleration, so it doesn't go higher than this. And then we're just dividing it by the max acceleration to get a 0 or 1 value. So then off of that, what we're going to do is we're going to get an unrotate vector node, and we are going to unrotate the vector with our character transform. So we can go ahead and grab our character transform out of here and split the structure pin, and we're going to grab the rotation and hook it up into B. So what we're trying to do with here is we're trying to transform the vector from a world space, meaning like, out here into the map, to the character's local space, like that you see here in the viewport, because that would, I guess, be considered its local space. And we're trying to make it relative to the character's orientation. So, when you first do your character or whatever, or you create it in the character blueprint, you'll notice how when you apply a skeleton or a mesh, to your character, so like for right here, the mesh, character mesh, that you'll notice that when you do that from scratch, that it will always look, so you have the red here, which is our X value, it'll always look on the positive value of the X, meaning like the right hand side. So it'll be like looking at us straight from this angle, but then we have to rotate it 90 degrees so it faces on the Y, because that's how we typically do it. Like in general, you can kind of do it however you want, in a sense, like, you don't have to follow the norm and rotate it 90 degrees to have it on the Y, but it is more of a standard practice and more, I guess, consistent with like learning processes and doing things. So, but this kind of also changes up how you have to also calculate certain values. So that's why in the animation blueprint that we're unrotating that vector, so that way it basically captures that local space within the viewport and not out into the third person map. So with that being said though, what we're going to do now is get a return node, and we're going to plug the value here into the return node. So now that we have that, we essentially got that. So I'm going to go ahead and clean this up for a moment, and I'm going to add my notes to it. So, and go over what we just did. So let me go ahead and do group movement, just like that, and then move that down here. So going over what we did is we're trying to limit the magnitude, or, you know, the velocity acceleration, you know, to our max acceleration value to ensure that we don't exceed physical capabilities. And then we're going to divide it, you know, what we have clamped out here by the max acceleration, which will result in a 0 or 1, and or 1 value. And then we're going to then unrotate that value so we get more of the local space, like of the viewport, you know, that character's rotation, in order to then get the proper return, you know, values that we want out of there. So, because we're going to be going over that in just a bit. So now we are essentially going to do the same thing. So honestly, what you could do is just copy this, and then let me control click acceleration, so that way we don't need it, and then paste that out to here, and then just plug the max braking deceleration into there, and then you've essentially got the next part that we need. But we also need to plug that into the vector clamp like so. So now we have that. So I'm going to move that down, and we can then add my other notes for this part. Let me go ahead and move my comment. All right, so just like that. And now let's go ahead and drag these over, and let's plug the true into our return node. So I just realized that it just messed that up. I guess, did I not? Oh yeah, I left that as comment. Oops. Let's go ahead and move that down. And then let's move this down a little bit. Move this down a little bit. And then I'm true on that return node and false on the bottom return node. And then we're going to prettify that for me. And boom, just like that. So now we have made this function and we're done with it. So what I'm also going to do is add my other notes just to go over it once more, because this is my big chungus note. Getting lost in the sauce. There we go. So now just to briefly go over what we just did. So this function ensures valid acceleration and deceleration values are used. It determines if the character is accelerating or decelerating by checking the direction of the acceleration relative to the velocity, which is here on our dot node. It normalizes the acceleration amount based on whether the character is accelerating or decelerating. And then our acceleration vector is converted to a local space to make it relative to our character's orientation, so kind of how it is in the viewport. And then we are making an output of the normalized vector between -1 and 1, indicating the relative acceleration amount in the character's local space. So that's what this is doing. So this is how we're getting our lean amounts, you know, for our additive to work properly. So now that we got that, we can compile and save it. And now we can go back into the lean amount, and we can grab the calculate. Oh yeah, I didn't make it a pure function. So go back into the relative calculation, and we want to make it a pure and thread safe function. Now go back into the lean amount, and we are going to drag this out, and we are going to split this struct pin. Oh, not promote. Geez. All right, there we go. We're going to split the struck pin, and we're going to, off the Y, plug that in there. So this may seem confusing of why we have the Y, but then putting it into the X here. So like what we just did in the calculate relative acceleration amount, is that we unrotated the vector so that it's normalized to our character's viewport space. So if we go back into our character, we're normalizing it here, kind of like how our camera is like over here and our character's looking, you know, forward in that direction rather than forward in that direction. So we're making sure that it is, you know, this way and not the red arrow X way. So once we do that, however, the animation blueprint doesn't know that, right? So that's why we're plugging into the X, because with the leans, we want to make sure that we lean on the X value. However, we want to do it when we're going forward. So that's why we're getting our, you know, forward acceleration and then making the adjustments on the X value for our leans or our additive mesh based off of our clamp. So as you can see, it's being multiplied. So when it generates a negative or positive number, it's going to be either multiplied on the, you know, by 0.5 or 1, which will get those leans that we looked at earlier in the video. So now that we have that, we can go ahead and compile and save. And then if we go back into the anim graph, now what we can do is here we can go in, and just to make sure I don't need anything else. So we're going to keep it on can be leader, where it can be leader as long as it has a higher blend weight than the previous best leader. We're going to make sure that we are not syncing it. We're not binding it to any functions. We don't have any relevancy or a relative anim node with the highest weight. And so what we're going to do is we're going to pin our lean left right to that function. So let's go ahead and look for it. Should be here, unless I'm overlooking. Oh yeah, I was overlooking it. So we're going to then, because we're trying to return the X value, we want to get the calculate relative acceleration amount of the X from our return. So that's what we want out of there. So then we're going to go down, and then we have a play rate of 1, and we keep our loop. We're going to reset playtime when blending, and then the start position we're going to keep at 0. And yep, we have additive leans, so there we go. So everything looks good. So now let's go ahead and on our apply mesh space additive, what we want to do is we want to bind it now to the is moving enabled function that we created for our, you know, movement analysis. So in order to do that, you're going to go up here to settings on the alpha input type, and we're going to change it from float value to a Boolean value, and we're going to pin that enabled Boolean to the is moving, just like so. So now when we compile and save, now you can see that we are back to normal with our character. So now you can see that even this updated to be similar to how it looks in GASP. So now that we have our blend space 1D additive lean run, based off of the function that we made, or actually hang on, because it's doing, my bad, I got it wrong. We need the get lean amount. Oh, my bad. Yeah, so I knew I was doing something wrong. So go on the get lean amount, make sure that it is pure and thread safe. So my apologies, compile and save. And then there we go, get lean amount on the X. That's what we wanted. So I was like, I knew something was up because I was like, why is it so long? I was like, I don't think I did anything wrong. Sure enough, I did something wrong. So now when we go ahead and play, and so yeah, I'm gonna go ahead and hit play in editor, because what we're doing is we do kind of like miss something, but this is off the GASP sandbox character that we migrated, and we don't have to worry about that because we're not using it. Oh man, as you can see, you know, we're doing pretty good. We're doing pretty good. It is just messing up. So, I mean, I'm pretty sure I know why it's doing that, and it's because, again, we have our main states and our locomotion and stuff like that set. So it's basically feeding into that while certain stuff is happening. So again, I believe that this is only doing that because of the stuff that we're lacking at the moment, as well as connecting it to the locomotion. So like I said, until I get to that point and have, better ways to test it and stuff like that, or at least show it off to y'all, it is just a theory at the moment. But I'm pretty sure that's what it is, because you can see that we are missing, a couple nodes where we're missing our aim offset, but that's also going to be messed up by everything. But we don't have our pose history, and we don't have the motion matching set for it to get like our blend time, updating motion matching, get the steering, get the orientation warping, because I want to save the motion matching for the finale. So I'm pretty sure that once we get through that, everything should be fixed. So at the moment, it is going to be buggy. So for the moment, what I do, want y'all to do is just kind of undo that and then just kind of go around it for the moment until we actually get that set. However, now that we have that though, we can go ahead and add the dev comment node into this, just like that. And then there we go. So now that we have the group movement and everything, and let's see, we can go ahead and just add it over here. Although we will need to move it for the next video. So as you can see, this apply mesh space additive node applies a left and right lean to the mesh base on the lateral acceleration of the character. Using the 1D blend space node as the pose input, the lateral acceleration is calculated using the get lean amount function. This pose is then applied additively to all locomotion animations. Upon the addition of arc animation coverage, this additive pose application would need to be adjusted so that it doesn't apply too much lean to the character during arc movements. So when you see that arc movements, it is basically this. So if I go into the UFN mannequins and run, you'll see these arcs where they're already leaning. So that's why they've already modified it the way they did, within the game animation sample project, is so that way they can avoid certain bugginess with those nodes. So other than that, that is pretty much it for this video, everybody. Like, I know it is glitchy for the moment, and like I said, it's probably due to the fact that we are technically overlapping or doing a bunch of stuff because of us being connected to the locomotion state machine and stuff like that. So once we can actually get rid of these, then we should be good. However, until we get to that video, I'm not quite sure. So I'm gonna go ahead and compile and save and just let it kind of flow through. So I'm just gonna bring that down for the moment. So, and then also too, to kind of quickly wrap up the video, I wanted to let y'all know that I did modify the where the foot placement is in comparison to the leg IK. I know in the the foot placement video that I did, I had them set side by side. However, me and Azure, we actually did a lot of discussions together in Discord where we did some research on this, and we eventually came to the conclusion that it was because of how the traversal animation is happening in the default slot and what it does in like timing and glitchiness with the foot placement. So y'all will have probably seen it in that video, or maybe have tested it yourself, where you'll notice that there is a lagginess or glitchiness in the legs and stuff like that, or clipping with the hands when trying to traverse, where that is happening because of the foot placement node. So I don't think it's blending correctly with the default slot node. So, and how it's like coming from the offset root bone and everything else. So we've discovered that if you place it beforehand, it will cover the foot just nicely. So to show you what I mean, let me go ahead and pull up the GASP project. So let me just, for a brief second, disconnect this, and I'm going to bring it over here, disconnect these nodes. I'm going to disconnect that and just drop it here, plug it into leg IK, and then connect this. So now if we play any minute now, there we go. So if we play, you'll notice everything looks fine. We get our feet warping going, we're just right. So you saw that there was a little bit of an issue there, but that's not really a problem. It's right here where you could see that he's not blending correctly when doing the traversal animations, mainly because of how the foot placement is actually interfering with that somewhere. So his leg kind of clips through or glitches through the wall, but then his hands also clip through the wall and don't catch up to the ledge properly. However, if we move that stuff back, so I'm gonna keep hitting Control Z until it comes back, and then we Control Save. So now that it's back in front of the default slot, when we go ahead and play, we'll still experience the weird glitch right there when I jump off the ramp. However, when we get up to the block, you can see that the traversal animation is fine now, and our foot placement is fine, and you'll see that when we get back onto the ramp, that it still does the proper slope warping and foot placements on there. So, and another thing you'll notice too is I gave them both a Boolean value of moving on ground, and essentially what I'm doing there is within the update states, all I'm doing is in the top, what we've come, to a conclusion of it being thread safe, because you have to be thread safe with it, is we just made a Boolean outside of here to just use into both of those. So it's technically thread safe. So when your movement mode is walking or nav mesh walking, it considers it you walking on the ground, and while falling, you're in the air. So that's essentially what we did. Is just true if you're moving on the ground and false if you're not. And then we just added it into here, and then also did the same thing for the leg IK. So we also believe that the leg IK, the reason why it's after the default slot is because technically I think this recorrects the legs after an animation is played. Because when we discussed it, what this does is it helps legs recorrect themselves, or twist corrections. It allows the legs to bend properly. It fixes a lot of other stuff, doing simple IK stuff with the legs that, otherwise could break after an animation montage or something like that. So that's probably why they have it placed afterwards. But if an Epic Games dev is watching my videos and knows more about this, I would love to see a comment by one of y'all explaining why y'all put the leg IK afterward and not before, just like the foot placement. So that would be cool if I can get one to respond, but if not, I kind of get the gist. So, but other than that, everybody, that is pretty much it for this video. So like I said, for the moment, our third person, or our template, is broken until we can finally get rid of the locomotion states. So that's why I'm going to have these disconnected for the moment, because in the next video we will be looking at the aim offset now that we've migrated all the assets. And then for my finale video, I will finish off with the motion matching node and post history node, as that's going to be an interesting video. Hopefully I get it out during the weekend. If not, it will be out next week, so definitely look forward to that. So other than that, if you did enjoy this video, guys, please check out my other videos and my future videos to come, like always. And y'all have a great rest of your day, and take care.